Good morning, Trig. We are going to start lesson 64. So before I start lesson 64, I want to review complex numbers. Now, complex numbers have a real part and an imaginary part. The real part doesn't have I, and the imaginary does. But when we go to graph these, they're graphed just like an x and y coordinate would be. So think of the real as x, so this would be real, and y is I. They rhyme. So if I was to plot positive 2 plus, there's an invisible 1 here, 1i. So positive 2 on the real axis and up 1i would be here. Negative 3, so negative 3, and then down negative 2i. So they're graphed very similarly. Let me label these. So this is A and this is B. So that is a review. We are going to be working with complex numbers today. So 64.A, there's really no work in that. They just go over how complex numbers look very similar to rectangular coordinates. It's all 64.A covers. 64.B, we're actually going to be converting from polar to complex and complex to polar. So I'm going to have you create 2 columns. And we're going to go over the different forms and rules on how we're going to write these. So I have a column for rectangular and a column for polar form. And then on the left, I have vectors and complex numbers. So in rectangular form, so vector, this is way back in lesson 14. Okay, when we originally went over vectors. In rectangular form, it's A vector I plus B vector J. But in polar form, I write our radius or hypotenuse and then the angle theta. And when we have an angle symbol as well as a theta. Now in complex number form, rectangular looks like A plus BI. Look how similar those two are. You see I in both, you see an A and B in both. So their forms are very similar in rectangular form. But if I want to write a complex number in polar form, I'm going to write R, and instead of this angle symbol, I'm going to write CIS and then theta. Now let me go over what CIS is. So this can also be written as R times the cosine of theta plus I times the sine of theta. And I want to show you where they're getting CIS from. It's an abbreviation for cosine, I, sine. So that is where they're getting these 3 letters. So this first form is just the abbreviation of the below form. Okay. Also, R should be the absolute value of R because R stands for the hypotenuse, and hypotenuse is the distance from the origin. So R will always be positive. Okay. So it is the absolute value of R. So it'll always be positive. So we're going to start slow. In our first example, I'm going to convert 2 root 3 plus 2i to polar form. So I'm starting with complex form, right? I have an A and I have a real and an imaginary, and I'm going to convert it so my final answer is going to look like this, RCIS theta. All right, so and remember that abbreviates for cosine, I, sine. So the first thing we're going to do, very first thing, is I'm going to plot 2 root 3 plus 2i and draw a triangle. This is not an optional step, okay? Please do this, okay? So if I had, and we're just predicting, these are both positive. So this is our real part. So that would represent my x value, and then I would go up to 2i. So this here is my 2i, and this down here is the 2 root 3. And so if I form a triangle with the origin, I'm looking for this angle here. And we can go ahead and erase the I, but those are the sides of your triangle. Now I'm going to label what I have. According to theta, I have opposite, and this is adjacent. So that's OA. So the trig function involving opposite and adjacent is tan. And because I'm looking for theta, I'm going to use inverse. So tangent inverse of 2 over 2 root 3 will equal theta. Now when I write it like that, I'm not sure if you can see that that can be simplified to the tangent inverse of 1 over root 3 equals theta. Now, when you see root 3, I think of my 30, 60, 90. So if this is 90, this would be 60. So I have 1. The hypotenuse is root 2. And, sorry, no, it's not. Why did I write that? My hypotenuse is 2. My long leg is root 3. So which angle, the 30 or the 60, has a relationship of 1 over root 3? Well, that would be this angle here of 30 degrees. So theta equals 30 degrees. I now need to determine, so I know theta. Yay! Now I need r. So r would equal, so r squared would equal 2 squared plus 2 root 3 squared, right? I'm trying to solve for r, and the hypotenuse, right? Because the 90 degree is here. So to find r, it would be the square root of 4 plus 4 times 3, and I'm going to enter all that in my calculator, and I got that r is 4. So I can now write it in this form. So 4 CIS 30 degrees. We found 4 and we found theta. And so that is our final answer once I solved for theta and r. Okay? So I'm going to try another one before we move on to do the reverse. So number 2, convert 5 minus 6i to polar form. So we're going to do the same process as number 1, but it's just a little extra practice so you can follow along and try it. All right, so the first thing I'm going to do is I'm going to draw a picture. So this is positive 5, but down to 6i, right? So this would be the positive 5, this would be the negative 6. You don't have to write I. This would be theta. This side here would be r. Okay, so that is my picture. I went to the right positive 5 and I went down 6. So no, I'm in quadrant 4. So let's find both theta. So the tangent inverse of negative 6 over 5 equals theta. Now this one, negative 6 over 5, that is not part of our special right triangles. That's not in my 45, 45, 90. Those numbers are not in my 30, 60, 90. So I am going to use a calculator to enter this. So I need to make sure mine's actually in radians, so I need to change this to degrees. And so I would hit tangent inverse of negative 6 divided by 5. And I get negative 50.19. And I'm going to round that to 0.2. Now, I'm actually going to keep theta positive. So, yes, if I was going clockwise, it's negative 50. But positive angles go counterclockwise. So, 360 minus 50.2. I'm going to use the positive version, which is 309.8. You can actually use either. I just prefer to use the positive angle when I'm writing it in polar form. So now I need to find r. So r will equal the square root of negative 6 squared plus 5 squared. And all I've done is I've skipped r squared equals a squared plus b squared, right? I'm just doing the Pythagorean theorem. And so for r, I get 7.81. So I have theta, I have r, so 7.81. CIS, cosine I sine, is 309.8 degrees. Okay, and if you're wondering where I'm getting these nice little letters, hold on, my screen locked me out. In our notes, it's R, CIS, theta, and I'm choosing the abbreviated form versus the long form. All right, so moving on, we are now going to work backwards. So I'm going to start with polar and work to rectangular. So convert 3 CIS 300 degrees to rectangular form. Sorry. So this is different, and that's why I'm doing an example just on going from polar to rectangular. The last two were rectangular to polar. So the first thing I'm going to do here is I'm going to rewrite in the long form. So this is really 3 times the cosine of 300 degrees plus I times the sine of 300 degrees. Now, if you'll notice right away, I've included I. The value of this will be A, and the value of this will be B. So I need to find the value of 300 degrees. Now, 300 degrees would put me here. And 360 minus 300 means I'm evaluating 60 degrees. But I'm in all students take calculus. I'm in quadrant 4. So I'm going to draw my values of my 30, 60, 90. Short leg is 1. This is 2. This is root 3. So I'm really evaluating 3 times the cosine of 60 degrees plus I times the sine of 60 degrees. Now, the reason I'm doing this, in case you missed this prior section, is I would have to use a calculator for this, and I'd get a decimal probably. So these are related angles or reference angles. So I can find it by hand using its related angle of 60 degrees. So the cosine of 60 is adjacent over hypotenuse, so 1 over 2. And it is positive in quadrant 4. Cosine is positive. Plus I times the sine of 60. Now, sine is negative here, and it would be opposite of over hypotenuse. So it would be negative 3 over root 2. So that is what I have. Here's the cosine value. Here is the sine value. So I'm going to rewrite this, all right, because I'm distributing 3. So this is 3 over 2 minus 3i over root 3 over 2. And they'd like us to keep the I separate. So 3 over 2 minus I 3 root 3 over 2. Oh, sorry. And that is our answer in polar form. In rectangular form, my apologies. But I just distributed, if you're wondering where I got that last part, I distributed 3. And so this, sorry, the I should go here. My bad. So this is your answer written in rectangular form. All right, so we'll try one more, and then we'll move on to 64.C. So yes, there is more. This is a longer lesson. -4 CIS 135 degrees to rectangular form. So again, I am going to first rewrite this. So this is a -4 cosine of 135 plus I sine of 135. So I'm rewriting it. Remember, CIS is an abbreviation of cosine I sine. Then I'm going to draw a picture. 135 puts me here. And 180 minus 135 equals 45 degrees. So this angle here is 45 degrees. So I'm going to label that special right triangle. That'd be 1, 1, root 2. So I'm going to keep my negative 4 out here. So I'm really evaluating the cosine of 45 degrees plus I sine 45 degrees. So they're both actually the same. So this would be 1 over root 2 plus, well, all students take calculus. So cosine is negative, but sine is positive. All right, so then from here, I'm going to distribute the negative 4. So I have negative, that would be positive, right? Negative 4 times a negative, positive 4 over root 2 minus 4 over root 2. I'm going to keep the I next. Now, unfortunately, I cannot leave a radical in the denominator. This is the part that people often skip. You do need to rationalize this. So I have to actually multiply root 2 to top and bottom. And I get 4 root 2 over 2 minus 4 root 2 over 2I. And I can simplify that. My final answer is 2 root 2 minus 2 root 2I. Phew. So that is converting from one form to the other. We are now going to move on to 64.C. I know it's a long section, but that's because I do a lot of examples, so that is a little bit easier for you in the long one. 64.C is finding the sum and product of complex numbers. And let's start simple. So the sum, when I do the sum, it can be written in rectangular form. So I can be added when written in rectangular form, meaning A plus BI. So number 1, I'm going to start over. I have 2 root 3 plus 2I plus 2 plus 2I. Now you can combine your real parts. So I'm going to combine 2 root 3 and 2, and I'm going to combine my imaginary. So if I go to combine the real, and then I'll write my imaginary, 2 root 3 and 2 are not like terms, so I'm just going to write exactly that, 2 root 3 plus 2, because I cannot combine them. But I can combine my imaginary, and that just gives me 4I. And that's the answer. So the sum is really, really simple. Now, the product is the following. So when I find the product, you are going to multiply R, but you are going to add the angles. So for example, if I have 4 CIS 30 degrees times 2 root 2 CIS 45 degrees. Okay, so I'm going to follow what I wrote here. I'm going to multiply R. So these we're multiplying because those both represent R, and these we are adding. So my answer, right, 4 times 2 root 2 is 8 root 2 CIS. Okay, and then I'm adding my angles, so 30 and 45 would make 75 degrees. And really from here, I'm going to go ahead and put this in normal form. So 8 root 2 is 11.3. So I get 11.3 CIS 75 degrees. So I got rid of the radical 2. That's pretty easy. And so we are moving on to the next one. So number 3, multiply the following. And it's going to look a little crazy, but bear with me. So multiply sorry, I need brackets. 5 parentheses cosine 20 plus I sine of 20 times 6 cosine 42 degrees plus I sine of 42 degrees. Now, the only thing they've done here is try to freak you out. They gave it in the long form. Remember, polar form can be written r cosine theta plus I sine theta, or we can abbreviate it to r cis theta. And so you and I are going to rewrite this in order to abbreviate each one, right? So this would just be 5 cis 20 degrees. Okay, I'm just using that abbreviation. And this one would be 6 cis 42 degrees. So you're going to rewrite it so that it's in that form. Sorry, paper is everywhere. And then from here, remember we multiply r. So 5 times 6 is 30 cis. And we're adding our angles. So 20 and 42 is 62 degrees. So pretty simple. I'm going to go over one more. 5 cis 280 times 7 cis 300. Now, when we write our answer, we want to express theta between 0 and 360 degrees. So when we express our answer, we want to use the related angle that's within that domain. So for this one, remember I'm multiplying these and I'm adding these. So 5 times 7 is 35 cis. 280 plus 500 is 580 degrees. Now I'm going to rewrite that to give the related angle. So if I subtract 360 from 580, I actually get 220 degrees. So I simply did 580 minus 360 because that is what the related angle would be. All right, so moving on, if it's not in degrees. So multiply 3 cis 2 pi over 3 times 6 cis 4 pi over 3. So if you are given it in radians, don't freak out. Just simply add them. They're probably going to already have a like denominator. So 3 times 6 gives me 18. You don't need those little lines. CIS 2 pi plus 4 pi is 6 pi over 3. I'm going to simplify that because 6 is divisible by 3, so I get 2 pi. Or you can write that as 360. All right, let's just review. So multiply and write in rectangular form. All right, so here we go. 2 cis 190 degrees times 2 cis 50 degrees. So if I'm to multiply this, 2 times 2 is 4. CIS 190 plus 50 is 240 degrees. To convert this, I would then have to rewrite this as 4 times cosine 240 plus I sine of 240. So if I was to draw that picture, here's 180, here's 240. So 360 minus 240 is, sorry, my screen shut out again. That's how long this video is. Or, you know what, why would I do that? Why would I do that? 240 minus 180 is 60 degrees. So this triangle right here, that's 60. So this is 1, 2, root 3. So I'm actually evaluating 4 times the cosine of 60 degrees plus I times the sine of 60 degrees. But all students they're both going to be negative. So the cosine of 60 would be negative 1 over 2. And then I'm going to put minus, right, because this one's going to be negative. The sine over 60 is root 3 over 2i. Then I'm going to distribute 4, and so I get negative 4 over 2 minus 4 root 3, over 2. This should be root 3, not root 2. So my final answer is negative 2 minus 2 root 3i. Phew. All right. I'm going to do one last problem, and I'm hopefully going to be able to squeeze this on here. Multiply and write in rectangular. So same directions as last time. So 2 CIS 45 degrees times 3 CIS 135 degrees. So if I multiply this, 2 times 3 is 6, CIS 45 plus 135 is 180 degrees. So I'm going to draw that. Here's 180 degrees, and my coordinates are negative 1, 0. So when I write 6 times the cosine of 180 plus I times the sine of 180, I get cosine is x, so negative 1, plus sine is y, so 0i. So when I distribute the 6, I just get negative 6 plus 0i, so negative 6. 0i you don't write. Whew, that'll conclude for homework 64. You're going to skip numbers 5 through 7, 13, 22, and 30. Thank you.